Lesson 21 Project Help Video. Sally and Chelsea are pterodactyls. Their friend Hannah, a triceratop, is having a party this evening 289 kilometers away from the village where Sally and Chelsea live. Luckily, pterodactyls can fly, so even though Hannah's party is quite far away, it won't take Sally and Chelsea long to get there. When Sally flies, she prefers to take off at a 7-degree angle, maintain a cruising altitude of 15 kilometers, and come in for her landing at a 4-degree angle. Chelsea, on the other hand, prefers to take off at a 13-degree angle, maintain a cruising altitude of 17 kilometers, and come in for her landing at a 3-degree angle. When at cruising altitude, both pterodactyls travel at a speed of 250 kilometers per hour. If you were to watch Sally's flight path while standing on the ground, you would see her trace out a path that looks like 3 sides of a trapezoid with a height of 15 kilometers. What is the approximate value of A? So if we were to look at Sally's flight, it'd be as if she's taken off here on this first one, then she's cruising, and then she's landing. So we want to know what's the value of A here. So we're going to look just at this first triangle here on the left. We're just going to look at the triangle. So we have a angle measure, we have a side measure, and we want to know a different side measure. So we need to figure out whether we need to use sine, cosine, or tangent. So SOHCAHTOA is one thing that will help you figure that out. It lets you know based on the sides that you have which one to use. So how SOHCAHTOA works is if we have sine, opposite over hypotenuse, cosine, adjacent hypotenuse, and tangent, opposite over adjacent. So we're going to look, we got 7 degrees. So we have 15 kilometers is our opposite side, since it's it's opposite from our angle. And then our A value here is our adjacent side, since it's right next to the angle. And then our side that's always across from our right angle here is always our hypotenuse. So the longest side is always our hypotenuse. So we have our opposite and our adjacent. So if we look at the last 2 letters of each of those, the one that has the O and the A is tangent. So we're going to use tangent. So we're going to have tangent of our angle, which is 7 degrees, equals, and then we have our opposite over our adjacent. So our opposite is 15 over our adjacent, which is our A that we're trying to figure out. So now we need to solve for A. So I'm going to first get rid of my fraction here. So I don't want to divide by A. So I'm going to multiply both sides by A. So now I have A tan 7 degrees equals 15. Well, I'm trying to solve for A, so I want my A value all by itself. So I'm going to go ahead and I'm going to divide by the tangent 7 on both sides. So now I have that A equals 15 divided by tangent of 7 degrees. So I'm now going to go ahead, I'm going to type this in the calculator. Make sure that your calculator is in degree mode so that you can find the tangent of 7 degrees instead of tangent of 7 radians. So ensure that you're on degree mode, and when you type 15 divided by tangent 7 into the calculator, you get 122.2 kilometers when you round it to 1 decimal point. So the value of A is 122.2 kilometers. Okay. What is the approximate value of C? So we got C over here, we got 4 degrees. Well, we don't have this side of our triangle, but since it's the same as our other side, we have 15 degrees is her cruising altitude, 15 kilometers. So we have 15 kilometers is our opposite side of our angle. Then we have C here, which is our adjacent side, and we have our angle of 4. So again, we're going to do tangent. So we're going to do tangent of 4 degrees equals our opposite, which is 15, over our adjacent, which is C. So I'm going to first get rid of my fraction again. So I'm going to multiply both sides times C. So I'll have C times tangent of 4 degrees equals 15. I want C by itself, so I'm going to divide by my tangent of 4 degrees on both sides. So now I have that C equals 15 divided by tangent of 4 degrees. Go ahead, type that in again, make sure that you're in degree mode. So when I type that in and round it to 1 decimal place, I end up with 13.0 kilometers for my value of C. Remembering that the total horizontal distance between Sally's village and Hannah's house is 289 kilometers, what is the approximate value of B? So that 289 means that here is where Sally's village is, here is Hannah's house. So that's this whole distance here is 289 kilometers. Well, we found in question 1 that our A is 122.2 kilometers. We found that that C is 13.0 kilometers. So we want to solve for B. Well, A plus B plus C here is our total. So we're going to have that A plus B plus C equals our total amount of 289 kilometers. So I'm going to go ahead and plug in my A value of 122.2 plus B is what I'm trying to figure out, plus my C value of 13.0 equals 289. I'm going to go ahead and combine my like terms, so I'm going to do 122.2 plus 13 and get 135.2 plus B equals a 289. Then I'm going to go ahead and subtract 135.2 from both sides. So now I have B equals, and then I'm going to do 289 minus 135.2, which is going to give me a 153.8 kilometers. So my value of B is 153.8 kilometers. When Sally is at cruising altitude, her speed is 250 kilometers per hour. Approximately how much time does she spend at cruising altitude? Well, our cruising altitude was just our middle part of our picture. So our B value that we just found out, which would be our distance that she's at cruising, it was 153.8 kilometers. And we have that her speed is 250 kilometers per hour. Now if we read the parentheses, it says that remember that speed is equal to the distance divided by time. So we got that speed equals our distance over our time. And pay close attention to the units. So I'm going to go ahead and I'm going to plug in what I know. So I know the speed is 250. I know my distance is 153.8 divided by my time, which is what I'm trying to figure out. So I want to get rid of my fraction first. So I'm going to multiply both sides times t. So I now have t times 250 equals 153.8. Want t by itself, so I'm going to divide by 250 on both sides. So then I get t equals, when I take 153.8 and divide by 250, and I round it to 2 decimal places, I get 0.62. And then if I pay attention to my units, so I had that my speed was kilometers per hour, and that my distance here was in kilometers, so my kilometers cancel out, so I'm left with that this time is in hours. So I have 0.62 hours. Now if this is a multiple choice question, it may ask me it for hours, it may ask it for minutes. So I'm going to convert that to minutes. So I'm going to take my 0.62 hours times, now I know that there are 60 minutes in 1 hour. Now I want to make sure that my hour is on the bottom, because then hour and hour cross out and I'm left with just minutes. So now when I do 0.62 times 60 divided by 1, I end up with 37.2 minutes. So I may have to type it in as 37.2 minutes or 0.62 hours depending upon which unit of time they ask for. That is it for your Lesson 21 project help video.